Now we go to the third heat treatment, sterilization. What are the objectives? When we apply sterilization, we destroy all microorganisms, including the spores. This works all a whole exactly in bracket. So we cannot destroy all. It's just all in commercial meanings, and we can use that word. Because some very heat resistant spore, for example the spore of Bacillus stereothermophilus, some spore of this bacteria can survive the sterilization. What is the target of sterilization? The target microorganism that we need to destroy to a safe level for sterilization? The spore of Clostridium botulinum. This is the target. Clostridium botulinum. Why the spore of this bacteria is taken as a target? Okay, because first, the spore is heat resistant. The second, this bacteria is a dangerous pathogen, produce neurotoxin. And the third, because this bacteria can live in condition like in canned product, in sterilized products, multiply there. So when it survives the heat treatment, it's called big issue. The spore of Bacillus stereothermophilus is even more heat resistant, but it's not taken at the target because this one is not a pathogen. This one is a spoilage microorganism, and this is called flat sour. We call it flat sour spoilage group. When Clostridium botulinum grow, it will produce the gas. If you have a canned product, for example, this bacteria grow and produce gas, so the lid of the can is swollen. But when this one grow in the can, it will not produce gas, so the product is spoiled, but the lid is still flat. And the product becomes sour because it produces organic acid. That's why the product becomes spoiled, but the can still look okay. So when the can doesn't look okay, then we should destroy this product because it's a high chance that this one grow. And sterilization will inactivate enzyme completely, more or less actually, because there are some exceptions. Some heat-resistant lipases and proteases derived from Pseudomonas group. What is Pseudomonas group again? Belong to cyclotrophic bacteria. This bacteria is not heat resistant, but the enzyme they produce are very heat resistant. In sterilization, you must understand the concept commercial sterilization or commercial sterile product. Commercial sterilization. There is no absolute sterilization. Means that you cannot say that I destroy 100% of microorganisms. But you do sterilization, you destroy up to the level that is safe for the public, and that is called commercial sterilization. Because if you review the cost, this is how microorganisms are killed by the heat treatment. And the more the time, the longer time you do heat treatment, the lower the number of microorganisms, but this curve never reach zero. This is exponential curve. That is why at beginning you have more, then after a period of time you do the heat treatment, you will have more. Beginning you have less, so after a period of time you will have less. The remaining number of microorganisms are dependent on the beginning number of microorganisms. Anyway, according to this curve, it will not go to zero, so you cannot say I do absolute sterilization. But people use the term commercial sterilization. Anyway, now we go next. Sterilization is also an indirect heat treatment. This is applied after filling. Okay, The temperature and time combination 109 to 115 degrees C for 20 to 40 minutes. Because you do after filling, you do after you put milk in the cans, in the box and so on. So you need a long time for the heat treatment. And then you do at low temperature. This is already low for sterilization. The steam is mostly used as the heat medium. Steam at high pressure. Okay. Steam at like positive pressure, high pressure, so that it can control at higher than 100 degrees C. Sterilization can be carried out under batch condition or continuous condition. When you do batch, then you normally apply retort, sterilizer. Sterilizer instrument is called a retort. When you do continuous, then you can use the hydrostatic sterilizer or tower sterilizer. We will see. And this system is suitable for glass and plastic bottles. Sterilization can be carried out continuously. And this is amazing. Right? Now, when you do batch, then you use a retort. Why a retort or sterilizer is so strong, is so robust like this? Why? To do sterilization, so you maintain the temperature higher than 100 degrees C, means that the pressure inside should be much higher than the atmospheric pressure. You work at high pressure, so the instrument should be very strong. And when you close it, then it should be closed as well. Alright? There are several vans, several like safety system and so on here. You can read the pressure, you can read the temperature several places inside and so on, to be sure that you control well the temperature to destroy microorganisms, but also to be safe for the people who work around. Because in case if you have an accident, if the pressure inside goes so high beyond the value that this instrument can stand, what happens? Some explosion may occur and then people may die. Then in Vietnam you hear time to time that things like this can go blast and people die. Very dangerous. So then we should really follow up well the maintaining procedure to be sure we work to have a safe product, but also safe for the people who work there. Now we go to the instrument, the sterilizer that can be used to work continuously. And this, what is the name of this one? Hydrostatic sterilizer. The other name is tower sterilizer because it looks like a tower. It's very tall. Hydro means water. Statics means still. Nước đứng yên. Tiếng Việt nó là gì? Thiết bị tiệt trùng kiểu thủy tĩnh. Đó là tiếng Việt. And in English, like this machine work under the effect of standstill water. Exactly not standstill, but the water doesn't run, doesn't flow. We already accept that to have high temperature, we need high or low pressure. High pressure. And in previous system, this system to maintain high pressure when you work, it must be a closed system. Everything is closed, right? Tightly. But now you look at the tower, it's not a closed system. It's very open. Now the belt that carry the bottle of milk or liquid product and the first column. You see, this is water, this is quite open. And the first column of water, this contain water. And then let's go into the middle column. It's actually, if you read the other book, this is called a leg. This is also called another leg. And the middle, they may call this doom. Okay? Anyway. Now, then the product enter the first column and go into the second column and then go to the third column and go out and further cool down by cool water. This is kind of cool water, and here you further cool it down and then you have the product. In the middle, to do sterilization, you need to maintain high temperature, 109 to 115 degrees C. Means that the pressure in the middle should be significantly higher than 1 atmosphere, right? And what then maintain this high pressure? Which one maintain the high pressure in the middle? In the middle column, you see it red. Red is actually steam. Steam maintained at high temperature. The pressure inside is maintained high because of the two columns of what? Of water, two sides. And this is the name of the system, hydrostatic. The pressure is maintained by the two columns at both sides. I will just explain here so you can see. If you have a cylinder, maybe it's like 2 meter height. If you have two cylinders of 2 meter height, and this one contain nothing, air, and this one contain water. What is the pressure at the top of the cylinders? What is the pressure here? 1 atmosphere, because it's the atmospheric pressure. What is the pressure here? At the bottom of the cylinder, at the left side, what is this here? Also 1 atmosphere. So if you measure the pressure here, like above here, it's 1 atmosphere. And if you measure the pressure at the floor here, it's also 1 atmosphere, right? But now, at the right side, you have a column of water. What is the pressure at the bottom here? Lower or higher than 1 atmosphere? Significantly higher than 1 atmosphere. What is the difference here? Because at the left side, you contain air or nothing. If you see nothing. But on the right side, what do you contain? Water. So the pressure here is a function of two things. The height and what? The density of the fluid. The left column, the left cylinder contain air. This is the fluid, but the density is almost 0. So you have like what? 2 meter, but it doesn't cause significant change in pressure because the density is almost 0. But here the density is much higher than 0. So you have a pressure. If here you contain air, but you go up to the sky, 10 kilometer high, where the airplane is flying up there, then the pressure here now significantly lower than 1 atmosphere. The density is small, but now the height is very high. So you see a what? Significant difference in pressure. This is the reason why on the surface of the earth, you boil water, water boils at 100 degrees C. But if you boil water up here, the boiling point will be lower or higher than 100? Lower than 100 degrees C. You can also just do this experiment. You go on the airplane, you drink water from a bottle, and now you have an empty bottle of water. You close the cap, and then when the airplane lands on the ground, what do you see happen with the bottle? Become smaller or larger? Have you ever flew with an airplane? You can do this experiment. You normally see that you don't need to do, because they normally give you a bottle of water, you drink and you close the cap, and then when it goes down to the ground, the bottle become like this. It will shrink, become smaller. Why it becomes smaller? When you are on the sky, you drink, you open the cap, you see the pressure inside and outside is the same, right? You close it, and now you go to the land, the pressure outside become higher. Then it will contract the volume. Many companies, they make the snack, you know, the chip. They make the snack chip. They have to fill gas in the bag before they put the chip inside. And when they bring this to sell in Dalat, you know, in Dalat, the bag normally become like this. It's quite difficult to sell. Even like this product, they normally do not serve on the airplane because it will go so big and maybe it's cause some explosion. Right, because different is pressure. Now we go back here. If you replace this normal water by marine water, by sea water, then the pressure here will be higher or lower. If this is not fresh water but marine water, then the pressure here will be higher or lower? Higher, because the density now is higher. Did you read about the accident with the submarine in Indonesia several days ago? Thường người ta thiết kế cái tàu ngầm là bơi ở dưới mặt nước khoảng mấy chục mét đến trăm mét thôi. Nếu nó bị tai nạn mà nó lặn xuống là coi như sao, cứu được không? Vô phương cứu chữa. Tại xuống dưới áp suất là sao? So again, this weapon submarine only work for a certain pressure. If it goes so deep, the pressure becomes so high, and then the high pressure may already collapse the submarine, and then may break the instrument already. As you see, so it's quite dangerous when you go somewhere this under the sea water, because you go the certain down, the pressure will be very high, much higher than the pressure with the fresh water. Now we go back here. The pressure here is what? What's the pressure on the surface of water here? 1 atmosphere. The pressure here will be significantly higher than 1 atmosphere because we have a what? A column of water. The higher the column, the higher the pressure here. The pressure here and here is the same. Here and here the same because it's the same level, the same height. The same height and the same fluid, you see? One fluid, continuous fluid, and same height, same pressure. And pressure here is high, whole pressure is high because the steam has the density of the steam is more or less like the density of air. So the whole pressure inside this column, in the middle column, is quite homogeneous. Okay? And then when you go out, the first column is for heating. The second column is for sterilization, for holding at sterile temperature. And then the third one is for cooling down. The pressure generated by water is because the height of the water, not because of the weight of the water. Remember, because the height, not the weight. You can do this experiment at home. You put a container here, you put water. If you stand here, you use a pipe, you put the pipe in your mouth and you connect to the water. You can use your mouth to suck the water up to from the container to your mouth easily. But then if you stand to the first floor of your house, you put a pipe down here and you try if you can suck the water to your mouth or not. You can only do that when you are strong enough to encounter the difference in pressure like this. Okay? The pressure here is what? 1 what? Atmosphere, because the surface of water on the air. So the pressure here is vacuum, much lower than 1 atmosphere, right? So you have to suck it very strong. Remember, the more you go up, the lower the pressure. And this difference in pressure is high because the pipe doesn't contain air now, but contain water. You actually can calculate what is the pressure here. Now we look at the temperature differences here. You see inside here the milk will be heated up. The temperature here is 80, here is 40, but the temperature of the steam inside 116 degrees C, and then outside you can cool down and so on. The principle. What are the effects and product of sterilization? Change in color is significant because of the Maillard reaction, because of caramelization. Milk contains sugar, so sugar may participate in caramelization, of course, at high temperature. And also Maillard reaction, because lactose is a reducing sugar, can react with amino acids at high temperature, and that is the Maillard reaction. This causes browning effect, and we change in color. Changing flavor is also significant. We have quite cooked and caramelized flavor. There are significant losses in vitamins, especially vitamin B, vitamin C. These are sensitive vitamins to heat. We may lose an important part. We even lose some part of essential amino acids like lysine, cysteine. These are amino acids essential, which are also sensitive to heat. We may lose a part of it. All these things are actually disadvantages, but you have a big advantage. What is that? Now the cell life is not days or weeks, but months already, and normally 1 year. This is the cell life of sterilized milk. In Vietnam, do we have pasteurized milk? Yes. Do we have UST milk? Yes. Do we have sterilized milk? You don't see in the market. Normally, they sterilize milk in a bottle, either plastic or a glass bottle, and the milk look quite brown in color. Other countries like in Europe, they still sell sterilized milk because this is actually the history of the milk industry. So they started first with pasteurized, they do sterilize, and then they move to UST. So many people are still already used to sterilized milk. They still like that caramelized flavor, that kind of color, that kind of specific aroma compounds and so on. And then they still like it, so you can still see it in market. But in Vietnam, we actually import the technology, so we go directly to UST. Now we have pasteurized and UST. So sterilized you rarely see in the market. Maybe if there is, and maybe some company import from somewhere else, but in Vietnam we don't process it. Now we take a break before we go to the last heat treatment.